Alright guys, in this video we're going to be tackling the Riemann sum applications using tables. So there's really two different ways you'll be asked to calculate Riemann sums, with a graph, which we saw in the last video, or with a table in this video. So in this table, we're essentially given function values, we just don't actually have to calculate them. So in some ways this is easier once you get the hang of it, because essentially what this is saying is if we were to take this table of values, we have some function where at 0, x is up there at, f of x is up there at 7, right? And then at 1, it's up to 12, up here. And at 5, it's some other value, 30 way up here. And at 8, it's up at 42. So whatever this function is, we just know some values of this function, which is all you really need when calculating a Riemann sum. Because when you calculate Riemann sums, think of these rectangles that we're drawing. If you remember the x values, that's sort of going to represent our width, and these f of x values represent our height. So that's all we need. We need some x values and we need some y values or f of x values for our height. So we're going to be asked to either do a left, a right, a midpoint, or a trapezoidal sum for these. The notation might just look a tad bit different. We're going to tackle this more in the upcoming videos, but this is actually integral notation. All right, we've seen this, except when we've done it before, we didn't have these little numbers here. It's called upper and lower limits. We didn't have those. Again, we'll be talking about where those actually come from, but this is just actually the integral notation for a Riemann sum. And let me go ahead and delete that. Actually, so the eraser doesn't work with this. Okay. Anyhow, so let's go ahead and see if we can figure this one out. It says we're supposed to do a left Riemann sum approximation with 3 subintervals. All right. Now, one thing with this is notice it doesn't say 3 equal. It does not say equal subintervals. And if you look at this, as we look at the gap here, the gap from 0 to 1 is just, 1. The gap from 1 to 5 is 4. And the gap from 5 to 8 is 3. So these aren't actually equal widths. Again, we know some values, but they're not equal width. And that's okay. This just means our rectangles might be a skinnier one, and then maybe a little bit wider one, and then somewhere in the middle for the next one, right? So that's okay. It doesn't say equal subintervals. Again, that's okay. We just need to make sure we use our values appropriately. So we're given 4 values. We're asked to do 3 subintervals. The reason we're given 4 is because technically we could do a left sum. Remember, on a left sum, we use the left endpoint, but we don't use the right endpoint. So with left, we start with the first, and we don't use last, right? And then when we did the right, we actually start with the second, and we don't use we do use last. Do use last one. Okay. Because we're using 3 subintervals. So we kind of ignore one, and we're not really ignoring it. We're just choosing to use the height of the other one. So essentially, these delta x's are going to be the same for a left or a right. And in fact, I'll do a left and a right here just so you can see how it works. All right, so let's go ahead and do a right sum. And I think this will make sense just as you do it. So a right sum, left sum, since that's what we're actually asked to do. We'll do that first. I haven't figured out where the eraser is on this new one. I guess you just got to clear the whole screen. Okay. So for a left sum, each of these areas, we're going to have, again, a width and a height. Okay. So the width of our rectangle is just going to be the change from our x's, because remember, x's dictate the width. So we go from 0 to 1. Well, that's a width of 1. So that's our width. And our height, now since it's a left sum, we're going to use the left number, choose the left one of those two. So we're going to choose a height of 7. Okay. And then plus our next delta x, or our next width, our change in our x is 4, because 5 minus 1 is 4. And then our height, we're going to choose the left one of these two. So we're kind of boxed into these two, and we're going to choose the left one, which is 12. Plus our next delta x from 5 to 8 is 3. And again, we're going to choose the left one, so we're going to choose 30. And that's actually it. Those are our 3 rectangles, our 3 subintervals. So we're just going to add those all together. 7 plus 48 plus 90. And let's see, that gives us 145. So that's our left sum. Now, if we were asked to do a right sum with the same things, the same values, our area, well, our delta x would still be the same. Our width is still the same. It's still 1. But instead of choosing the left one, we're going to choose the right one. So we'd actually use 12. So 1 times 12 plus our next one is 1 to 5, so that'd be 4. And then again, we're going to choose the right one of these two. Okay, the right one is now 30 plus our delta x there, our width is 3. And we choose the right one, which is 42. So also in calculating these, we can't pull the delta x out because the delta x's are not the same in this particular example. So you can't factor out that delta x like we did when we looked at the graphs. Okay, so this is going to be 12 plus 120 plus, let's see, 126. So we're going to get a significantly different value, 246, so like 258. So a much different value from the left and the right sums on this one. Again, we were just asked to find the left sum, so we're going to type that in. It's going to be 145. Okay, next one is a trapezoidal. All right, so let's see if we can remember what to do there. All right, so with the trapezoidal sum, remember when we did these, a trapezoidal area is like 1/2 b1 plus b2 times the height, right? Okay, so in these, the b1 and the b2s, those are going to be our f of x values. And the height, if you will, is going to be our x values. So that's sort of like the width. So this is sort of the width of it, right? And this sort of represents the height, if you will. Because we looked at trapezoids that were sort of this way, right? So the width of it is this. This is our x values. That represents the height of the trapezoid. It's the width as far as we're concerned. And then each of these heights represents, this is like our b1 and our b2 here. This is sort of our h. So we can kind of visualize it in that way. All right, now it does say 5 subintervals. We should be given 6 values. 1, 2, 3, 4, 5, 6. Yeah, so we got 6 values. That's exactly what we should have. Because if you remember, when we're doing this, we'll go through and I'll show you, but there's a shortcut. We'll just go through and do each one of our little trapezoids, and we'll show you how it pans out here. All right, so if I have 5 subintervals, that means we should have essentially 5 trapezoids. 5 trapezoid formulas. We got 1/2. Our b1 of our first one is going to be 7 plus our b2. So this is like our b1 and our b2. All right, 7 plus 10. And then our height represents the change in x. So that's 0 to 4, which is 4. Okay, so that's our first one. Our next one, then plus 1/2. Our b1 now, we're just going to shift over a little bit. This is now sort of our b1, the 10 is, right? And this would be our b2. So we've got 10 plus 20 times our height, which is the change in the x. 6 minus 4 is 2. So times 2. Plus, drop down for our next one, 1/2. Hopefully you're starting to get the hang of it. Now we've got this 20 is our b1, and that 26 is our b2. So 20 plus 26, and then times the width, which is 6 to 8, which is 2, plus, just keep this pattern, 1/2 times our B1, which is now 26. Our B2 is 33. Times our height, 8 to 10 is 2. And then the last one, plus 1/2 times our B1, which is now 31, or 33, and our B2 is 47, times our height of 14 minus 10, which is 4. All right, so there's a lot of work there. You can, in all of this, you can pull out the 1/2, all right, because the 1/2 is common in all of these, so we could pull that out. Now, another shortcut that we're used to with the graphing one is to pull out the delta x as well. However, you'll see that you can't pull out the delta x because that changes in all these. Here it's 4, there it's 2, 2, 2, and then it's back to 4. So you can't actually pull out that delta x. You can't do that shortcut. But you can pull out the 1/2. I guess that makes things a little bit easier. So you pull out the 1/2, and then just do each one of these individually. So we've got 7 plus 10 is 17 times 4, which is 68, plus 10 plus 20 is 30, times 2 is 60, plus 46 times 2 is 92, plus 59 times 2 is 118, plus let's see, that's 80 times 4, it's 320. Hopefully I did all that math right. Might want to use a calculator for this one. And then we need to take half of all that. So we're going to divide that by 2. And hopefully we did the math right, and it is 329. All right. So trapezoid probably takes the most work. It's really important that you know the trapezoid formula. So if you don't know it, area of trapezoid, because as long as you know these formulas, you can figure it out. Just draw it out and you can figure it out. But you do need to know these basic formulas. So let's type that in, see if we did it right. All right, there we go. Okay, let's go ahead and try another one. Clear the screen here. Let's see, this is a right Riemann sum. Okay, let's try that one. All right, right Riemann sum, and it does tell us to do how we're going to get back to, all right, right Riemann sum. Sorry, the things are a little different here today. Right Riemann sum, and we're supposed to do 5 subintervals. And notice there's 6 values. There should always be one more than the number of subintervals in these tables. Should always be the case. All right, so this one won't take long once you get the hang of it. We'll just think of, oh, we should have 5 rectangles. So I need an area of 5 rectangles. They're all length times width. Again, this represents our width. This is sort of our length or height, if you will. So we'll just go through, calculate the width of each one. This one is 0 to 4, so it's going to be 4. And then times our height. Now we're asked to do a right Riemann sum. So we're just going to start with the right value. We don't include the first one. We do include the last one. So we're going to start with our height of 5. So 4 times 5 plus our next delta x is 7 minus 4, which is 3, times our height. We're just going to go to the next one. It's 14. Plus 7 to 10, that's a gap of 3. And our height, we're just going to choose the next one. It's 24. Plus 10 to 12 is 2. Height there is 31. Plus 12 to 14 is 2. Height there is 32. So we've got 1, 2, 3, 4, 5. 5 of them. We used the right as our height, so we did not use the first f of x. We did use the last f of x. That's exactly how it should be. So let's go ahead and do this calculation. 20 is 14, 42, 672, 62, and 64. Let's add those on the calculator real quick. All right, and we get 260. If we were to have done the left Riemann sum, would have been very similar if this was a left. Show you real quick. The delta x's would be the same, so it'd be 4, and then we'd start with 1. So 4 times 1 plus 3 times 5 plus 3 times 14 plus 2 times 24 plus 2 times 31. Very similar, not hard to do. All right, let's go ahead and type that in. It's 260. That's it. I do want to do a midpoint. There we go. All right. This will be the last one here. You'll at least have an example of all of them. All right, so midpoint Riemann sum. And this, let's go ahead and, so we're supposed to use 3 subintervals. Notice we've got some extra values on this one. Intuitively, it's actually pretty easy because you can see on all of these. So we're supposed to use 3 subintervals. Then you'll actually see we have sort of 3 middle values here. Right? So we've got values for this one, and this one. So again, intuitively, you can kind of see how these rectangles break down. Because remember when we're doing the midpoint, we want to choose sort of the middle of those 2 values, middle of the x values. If this was 2 and this was 5, well, then we use whatever the middle value there, 3.5, is to determine the height. So we don't use the left to determine the height or the right to determine the height. We choose the middle of those 2 to determine the height. Now, one thing that's a little bit tricky is calculating the width. The width of each one of these is still going to be from here to here, because we're actually, this is like a rectangle here, if you will, and then this is a rectangle, and then this is a rectangle. So we're just using that middle value to determine the height of it. So we're going to be using this f of x value to determine our height rather than choosing the left or the right. However, our delta x, or the width, is still going to be from 2 to 5, and then from 5 to 8, and then from 8 to 11. Okay. So the width of our first one will be 5 minus 2, which is 3. And then again, rather than choosing the left or the right, we're going to choose the middle value, which it gives us here of 3.5, and that height is 13. So that's what we're going to use to determine the height. We don't actually use 3.5. That's just the middle of those 2, and then we're choosing the y value that corresponds to that 3.5. Okay. So plus, the next delta x is from 5 to 8, which is 3. And then again, we're using the middle of that for the height, which is 34, plus 8 to 11, which is also 3. And we're choosing the middle of that, 9.5, using that height, which is 41. And that's actually all there is to it. Just go ahead and do that math. And you could actually just pull the 3 out, 13 plus 34 plus 41, and multiply that by 3, and we get 264. So that really is all there is to it. Okay, so there's an example of each one of those. Hopefully that makes sense. If you still are a little struggling with those, make sure you do let me know that you're struggling with the delta math, and I can either arrange to help you, or we can work something out. So, all right, good luck with those, guys. And remember, you can always watch the help video as well. There is a help video. He'll explain it. I think he actually draws the graphs there. So that might even be a better way of explaining it. I don't know. You can check that out. And again, feel free to let me know if you need more help.